another DeFi tutorial for you. I'm super excited to share with you. So, first and foremost, thanks to everybody who came out to the career building masterclass last week. We had a great turnout for that. As always, keep an eye on the announcements in the chat room to know about those next masterclasses as soon as they come out. We got our next masterclass in the works for next month. I'm super excited to share with you. I'll tell you about that more as the official announcement goes live, but stay tuned. But this week, I got another DeFi tutorial for you. We're talking about how to actually implement other DeFi applications into your smart contracts so you can create your own blockchain-based applications. Okay. So today we're looking at the Aave protocol, right, which is one of my favorites. It's one of the most important dApps on top of Ethereum. And we're actually looking at how to plug into the Aave smart contracts, do a deep dive on how they work, and go through a sample application that you can create. I'll show you how to do this. We got the whole code here. You see a link down in the description below to download this and get started. So Zed's done some great work on here. If you guys haven't said hi to Zed yet, he's my new right-hand man who's been helping me with these tutorials and also helping support you all, answer all your questions into that chat room. So Zed's done a great job. Everybody give him a round of applause if you see him hanging out in the chat room. So let's go and get started here. So what is Aave? Well, it's one of the most important applications on top of Ethereum right now, and not just Ethereum. So it's a DeFi application. It's a savings and lending app, so you can deposit cryptocurrency into it, like any of these assets here. You can take out loans on the other side. You can see the interest rates available here. So, Aave was one of the original applications that kicked off the big DeFi boom that happened at the beginning of 2020. It has since expanded over to other blockchains like Polygon. And that's one you guys are pretty excited about here. You can see different marketplaces, Aave version 1, Aave version 2, Aave on Polygon. I know a lot of people are very excited about Polygon. We're going to be covering that pretty soon. Some of these next videos coming up. So make sure you check out the video vault in the announcement whenever those come out. But anyways, Aave is a pretty amazing application. Let's people deposit cryptocurrencies, earn passive income that way, take out loans the other side. And so I'm going to show you how the architecture works because this is really great. If you're building a DeFi application, you have to understand this stuff, how to integrate with real world smart contracts on the blockchain. I'm going to show you that exactly in this video. We're going to take a look at Aave, how to add your smart contracts, but also how to connect to the Ethereum blockchain to work with real world blockchain applications that are actually out there in the wild. Because sometimes, coding your own smart contracts in a sandbox on your computer is awesome for learning, but if you want to take those learnings to the next level and actually work with real world applications, how do you do that? How do you actually get access to those smart contracts that are out there in the blockchain with their state and functionality to use it like a money Lego inside your application? So that's exactly what I see in this tutorial. So go ahead and pull down that coding resource. We'll go ahead and get started. There should be a zip file where you can get that. So go ahead and open it. Open your terminal. All right, you'll see your project here like this. We'll go through the setup steps that you can see in the README. We'll go over the about here in a second. But basically, go ahead and clone the repository. You can just download it with the zip file. You won't have access to this actual repository. It's private. But you want to enter that directory. And first you want to install your dependencies like this. So npm install. All right. So I've already done this step. I'm going to skip it for now. But you definitely want to wait for your dependencies to finish before you do that. Okay. So our next step is going to be make sure you have Truffle installed. So that's the smart contract development framework we're going to use. So you can see Truffle version. All right. So I have Truffle installed already. I'm using version 5.1.67. And if you don't have it installed, you can npm install -g Truffle. Okay. And then next you want to make sure you have Ganache CLI installed. So what is that? Well, Ganache is a development blockchain, okay, that lets us run a blockchain on our computer. And you probably see my tutorials if you haven't already. Where we install Ganache, we're actually going to use the command line version of it. That's what Ganache CLI stands for. And basically that lets us create a blockchain on our computer. Okay, so Ganache blockchain. Let me make that font a little bigger. So Ganache ETH blockchain. So we can install a blockchain on our computer like this. But what Ganache CLI would let you do is actually point this blockchain to the real Ethereum blockchain. All right, so this is important because we actually want to develop with the Aave smart contracts because they are already deployed to the Ethereum blockchain. And we want to get access to those because they contain important information on the blockchain, like who owns tokens in the smart contracts, who's already deposited, who's already taken out loans. So we're going to connect our blockchain, our Ganache blockchain to the ETH blockchain and actually interact with the real live Aave smart contracts with Ganache's forking feature. So you won't actually be spending real money on the Ethereum network, okay? You'll just be getting a copy of the Ethereum network kind of at current point in time. Essentially what you do is you freeze the Ethereum network and you point your Ganache blockchain to it. And then that allows you to interact with the blockchain at that point in time, okay? So I'll show you that. But that's what Ganache CLI allows you to do. So you want to make sure you install Ganache CLI like this, npm install -g, Ganache CLI. All right, so I've already done this. I'm going to skip this step. And you definitely don't want to type in the $sign if you're brand new coding. Just skip that. That just stands for terminal. Okay. So now what you need to do, in order to complete this step, to point your Ganache instance to the Ethereum blockchain, what you want to do is actually, let's see here. You want to connect to an Ethereum node, and that's exactly what we're going to use Infura for. So Infura is an Ethereum node as a service. You don't have to run your own node in order to install it. Basically, you're going to just sign up for an account. You'll get access to an Infura node. They'll give you a URL where you can link to it, essentially. You'll need to create an app. You'll see your apps here, and you're going to click on one of these apps, and you'll see a link inside of there that has the connection to your Ethereum node. You can see it like this. You'll see something that's kind of like this, but you'll actually want to put in your real API key here. So he just put ones in the documentation, but you want to put your actual API key in here, right? So you want to do Ganache CLI-F, which stands for fork. So you can fork the Ethereum mainnet, and you can actually take your API key and put it in here. So I'm going to do it off screen because I'm not actually going to share mine, but just go ahead and replace your API key there. I'll get mine here. So go to the app, go to settings, and then copy the HTTPS version of your URL there. All right, so I'm going to paste mine in off screen. And once you do that, just hit enter. All right, so I'm doing mine on screen. Okay, so once you do that, let me just show you. You should see a screen like this. I've scrolled so I don't have my Infura URL on the screen. But anyways, it'll show you your available accounts. So you get 10 accounts for free. You get their public keys and their private keys. As always, don't put real money in these private keys or any of these accounts because everybody who's watched this video or has access to your development logs gets to steal your money. Okay, so never put real money in these development wallets. All right, so now what we're going to do is actually let's make sure you have the other things in place. So of course you need you've got everything. You also need a MetaMask wallet. Okay, so you'll need a MetaMask wallet installed. So you can always just Google this and look for MetaMask Google Chrome if you haven't installed one already. What we're going to do is actually take one of these applications, take one of the private keys, we're going to copy it, and we're going to put it into our MetaMask wallet like this. We'll go like this, we'll import account, paste in your private key, click import. I'm going to do the first one. Okay, so this is our, our Ganache wallet here. Okay, and then now we're going to actually point our MetaMask to localhost 7545. So let me just see here. That's right, 8545, my fault. So do your thing here, 8545. All right, so now you're connected to Ganache. You can see you have 100 ETH in your account. So now we have an app running, and I'm going to go ahead and open my terminal in a new tab here. We've installed the dependencies. We have pointed our Ganache CLI instance to the Ethereum mainnet, or at least a copy of it. We've imported our account to MetaMask. And so now we're going to just run the app. So what we want to do, we have some smart contracts in there. I'll get into the code of that in a second, but we can take a look. we can look at source contracts. We have some contracts already coded. We'll get into the code here in a second, how this works. But let's actually migrate the contracts. Okay, so we're going to do truffle compile. All right, so it's actually compiling the contracts, make sure everything works properly. And we're going to do truffle migrate -- reset. And that's going to put the smart contracts on the actual Ganache blockchain. I think I might have missed a step here, actually. I think I might need to import my private key into the project first. Or maybe not. No, we're okay. We're okay. Yeah, we're okay. All right, so we have contracts on the blockchain. All right, and the next we want to do is run the test to make sure the application works. So truffle test. We'll go through all the testing and everything here in a minute. All right. Great, that works. And then now I'm going to open a new tab here. So npm run start. So this will actually load a client-side application and automatically open up in our browser like this. So it's starting the development server. This will take just a second. Wait for that to finish. Okay. All right. So there we go. We have a front application there. So the CSS has got a little bit off. That's okay. You can fix that if you wanted to. But essentially what this app does is it shows you how to do lending and borrowing with the Aave application inside your app. Okay. So let's take a tour of the code and see how that actually works. All right, so let's open back up into Sublime Text here. That's just a text editor of choice, or my text editor of choice. You can use whatever text editor you want to. I'm just going to open like this. Okay, and so if you go to source contracts, you'll see the main contract that's coded for this particular application. Okay, so there's one major function inside of here. All right, and this major function is borrow DAI against ETH. Okay, so let me show you how Aave works. Basically, what it does. Now Aave is a little more complex than this, but here's the general overview. So we have Aave. Aave is it's an application with multiple smart contracts, but it has a essential interface that lets us do, the specific functionality here. Where you can the user interface on Aave lets you essentially, deposit money here and borrow money here. But how Aave works is it's a collateralized lending platform, over collateralized. I think I missed a spelling error here, but you get the idea. So what you do is you have to deposit one cryptocurrency in order to borrow another. Now some people say, why would you want to do that? Well, basically the whole idea is, if you think cryptocurrency prices are going to change and you want to borrow a stablecoin against a price, cryptocurrency is going to go up over the long term, you can do that. Use it for leverage trading. If you want to short a cryptocurrency and expect the price to go down, maybe you could do it for that. There's lots of reasons people do this for DeFi, but those are some of the ideas. Basically, in our study, what we're going to do is we're going to take Ethereum cryptocurrency, ETH, because we already have that in our wallet provided by Ganache. All right, we're going to deposit ETH into Aave, and at the same time, we're going to turn around and borrow DAI. Okay, so DAI is a stable cryptocurrency whose price doesn't change. All right, so we're going to deposit ETH and we're going to borrow DAI. Okay. So if you see that, you can see that's what we're going to do here inside of this application. It has one main function, and this is how you do it inside your smart contracts. You borrow DAI against ETH. That's the whole idea. You're depositing ETH and you're borrowing DAI. Now you can do one of the benefits of doing this in smart contracts is, of course, you're going to see how you can create smart contracts that interact with other DeFi apps like Aave. So you think about DeFi applications being like money Legos. You can plug different applications into one another to come up with new recipes about new possibilities that aren't readily available on the blockchain. Maybe you want to create a bot that does this whenever you're trading. Maybe you want to create a DeFi bot that lets you get certain benefits that don't exist in other applications. Maybe you want to create a new DeFi app altogether, a DeFi dashboard, lots of different things. Okay. So the whole idea, that's the type of thing you're going to learn how to do. But the key benefit of not doing it with the Aave user interface is you can do it all in the same transaction with this smart contract. So essentially, you can deposit ETH, with one. All in one go. So anytime you execute a single function outside of a smart contract, some function call, everything happens just step by step. Okay. So that's what our app's going to do. So let's kind of step through the code to see how it works. So of course, whenever we code this function, is a payable function. So that means we'll send in a certain amount of Ethereum cryptocurrency or Ether whenever this function is called. That's how smart contracts work. Basically, whenever it's payable, you can call the smart contract function. Okay, but you can also send it in Ethereum cryptocurrency or Ether whenever this happens. Okay. So we make it payable. All right. We keep track of the total deposits for the person who has deposited into the application here, this mapping. All right, so this mapping is right here. So this is a mapping where it's a key value pair. We put in your address and we return the amount of ETH that you deposited with an integer. Okay, of course we put this in the wave value. This is total ETH deposits. All right. And then basically we set up the variables that are required for the Aave WETH gateway. So what is the WETH gateway? So when we see I'm kind of talking about Aave as a single concept here, but there's multiple things inside of this. Okay, so we're going to look at the WETH gateway. So what is WETH gateway? Well, basically, whenever you're depositing cryptocurrency DeFi applications, you have two different types of cryptocurrency. You have Ether, okay, and then you have ERC20 tokens. So ETH is the native cryptocurrency of the Ethereum blockchain. It doesn't work like tokens. ERC20 tokens lets people approve cryptocurrencies to be spent on their behalf. It has a transfer function, and Ether has none of those things. Okay, it has a transfer from function. And Ether does not have that. So basically, what you do is you wrap ETH to an ERC20 token. That's what WETH is. And Aave uses a special WETH gateway that lets you essentially convert your ETH into wrapped Ether, or WETH. That's what WETH stands for, wrapped Ether. And that's the first step in actually doing this over collateralized lending, is converting it to converting ETH to WETH. So that's what this WETH gateway is. So WETH gateway, you deposit ETH like this. Deposit with value equals MSG.value or message value. This is the global variable in Solidity that lets you know how much Ether was sent in with this transaction. That's what we have table here. Okay, and so the variables here are going to be the lending pool address on behalf of, and then the referral code. So what do these variables mean? Well, we have the lending. So we have the WETH gateway as part of the Aave stack. We have the lending pool. So the lending pool is the thing that actually does the lending, all right, for the borrowing and lending, the lending side of the equation, all right? So we deposit ETH into the lending pool, and we see the address of the lending pool here, okay? So essentially, Aave has something called a lending pool address provider. Okay, we have these sort of settings already set up for you inside of the application here. You can actually see more about this in the Aave documentation. So you can check the Aave documentation here. You can see the lending pool. Or you can see the protocol overview, which this is probably better to look at here. So basically, you have the deposit, withdrawal, borrow, repay. All right, we have trades, flash loans, all that type of stuff. We can see the different actors in play here. Okay, so you can see the different parts of the smart contract in the architecture. So the lending pool. All right, you use different methods applied to this. I'll also put this in the links down below as a reference. So we have the deposit function, all right? We have the ETH gateway, which we're seeing here. So we have the deposit ETH, that's what we just called here, to actually deposit. You can see it accepts a lending pool address, the on behalf of the referral code. So we don't care about the referral code. This is like a referral program. That's not really important for this tutorial, so we just leave it as 0. On behalf of is going to be the smart contract itself. So whenever we're doing deposit, the contract's actually the one that's depositing into the lending pool. Okay. And then we have, the lending pool address, which we just got from the documentation here. Okay, you can see the source code we've out here. If you want to see all the deployed contracts, like here's a master list. Basically, this is where all these addresses come from that you see inside of here. You know what I mean? For all these variables that are set up inside the constructor function, that's where these addresses come from. This is the source of truth. And the cool thing about Ganache CLI is we're able to actually interact with these contracts that are on the mainnet because we forked it. Okay. So, yeah, so we deposited ETH. That's the next step. So now we have a price oracle, which we set up here. So now we have a lending pool in play. Now we want to talk to the price oracle. Okay. And what this is going to do is let us know what current cryptocurrency prices are so that we can actually do a borrow, because Aave will only let us borrow a certain amount based on the Ether price. Okay, so the Ether price is not available on the blockchain natively. We have to use outside data, like what is the price of Ether on exchange, and we use something called oracles to do this. Basically, oracles provide outside data to the blockchain. Aave has some built in. Okay, so the price oracle is going to get the current price of the DAI token. Okay, so that's the next step here, DAI price, and we make sure the price isn't 0. So basically, this worked. And then the next thing is we're going to. And one thing that's important is the DAI to ETH price. So basically, what is the price of DAI relative to ETH? So now what we're going to do is actually do something that we do the borrow. Okay, so we talked to the lending pool. We did the borrow function. You can see that here in the documentation. Let's see here. See lending pool. So we did deposit already for the ETH gateway, and then we're doing borrow here. So what does it take? It takes the asset you want to borrow. In this case, it's going to be DAI. The amount you want to borrow, the interest rate mode, the referral code is going to be 0, and the address on behalf of, which is going to be our smart contract. Okay. So we put in the DAI address as the token we want to borrow. So the safe max DAI borrow is something we're actually just going to pass in. Okay, so basically, you want to calculate this yourself for the sake of this tutorial. If you want to make your smart contract more robust, you can do essentially you could use Aave's collateralization factor to determine max loan to value. So I'll explain that for a second, like collateralization factor. So essentially, this is like how much of your collateral do you want to borrow. So for example, if you did 75%, that means if you deposited 1 Ether, let's say at a price of $2,500, you'll say 1 ETH, at $2,500, then basically, if you can borrow 75% of that, let's just do a calculator. We're talking about 1,875 DAI, roughly speaking. Now, DAI is not always perfectly pegged to the US dollar with ETH, but it's pretty close. So you'd be borrowing about $1,875. Okay. So you could play around with this. If you try to borrow, $2,000, that's probably gonna be higher than the appropriate collateralization factor. If you borrow, $5,000, of course, it's gonna blow up and not let you do that either. Okay, so, anyways, then we keep track of the total borrows, which is something we hard code into our app here. So basically, we just take we put a mapping here that tracks the user's borrows. So we track the total ETH deposit, total borrows. Okay, so here's the mapping. All right, and then we update that value here after the borrow, and then basically, whenever we finish that, we essentially transfer the DAI that we just borrowed back to the person who called this function. So that's what this is. So we basically take an ERC20 version of the DAI token, we just set it up like this, and then we use this require statement to make sure that the DAI token is transferred back to message.sender, or the person calling this function. Okay, and we put in this same amount that was just borrowed here. And then lastly, we just emit a custom event inside Solidity that lets us know that this happened. And this is how you actually create a custom event like this. We just log all the data from this function call to the blockchain itself. All right. So, yeah, that's basically how it works. So essentially, we're going to deposit ETH into Aave, borrow DAI, but inside this function call, we're actually going to receive DAI back. We don't have to withdraw from the contract. So the whole idea is you just, with one step, you click a button, you have Ether in your wallet, you tell how much ETH you want to send, and after you finish this function call, you get DAI back. All one function call, it's seamless. You can plug this in multiple other applications, and that's exactly how you implement it into your smart contracts, just like this. Okay. So let's take a look at the tests, because the test is going to show us even more how it works. So we can look at this Aave DeFi test. So we put in the smart contract addresses here just to check everything. We have a miniature ABI that just gets the important parts of the Aave smart contracts we care about, right? Like balance of and decimals. And this is actually for, sorry, not Aave smart contracts. This is for the ETH reference, okay, and DAI. All right. So we track the deployment, so make sure that the name is correct. If you want step-by-step tutorials on how to write these tests, of course, check out those step-by-step tutorials I have on YouTube or inside the Blockchain Bootcamp if you've done any of those, and these should look really familiar. But we make sure that the variables are correct for the addresses. Okay. But then we actually test the function call here. So we check your ETH balance before, we check the DAI balance before, we track the deposits and the borrows. We basically track the entire state of the smart contract before you call that function, and then we check that this happened after you call this function. Okay, so your new ETH balance is correct, your new DAI balance is correct. It emitted the event that we expected. All right, and this will give you some ideas on how to write really robust tests to make sure that everything works properly inside your smart contracts for real world applications. This is a great idea here. Okay, so those are the tests, and of course we ran those when we set up the video here, so you can see the results of the test here. So I'll just pull this off screen, make sure I can see it. Hold on. Yeah, here's the tests. So you can see the ETH balance before, ETH balance after. Okay, you can see the DAI balance after. All right, awesome. So let's go ahead and actually boot up the front-end application here. So let's go see how that works. Let's look at the front-end application code. So you can see source, so components. This is a React.js application, but it does a lot of what our test does. Okay, so basically, if you've done any other tutorials, this should look really familiar. We have the component wheel mount that adds all this stuff in here. We connect the blockchain like this. Some of this is too fast, looks unfamiliar. Definitely go check out those step-by-step tutorials where we set all this up and show you how to do it. All right. So we load the blockchain data, we pull in the smart contract, we load all this other information, the total ETH deposits, DAI borrows, DAI Ether price, ETH balance, and then we actually have the function called to borrow DAI right here. And you can call this, all right, inside of this button down here. Let's just find it. Yeah, right here, on click, borrow DAI. So let's see how this looks in the front end application. So borrow some DAI from Aave after depositing ETH. So basically, let's just put in 1 Ether, click borrow DAI. So let's actually make sure our app's connected here. Connect. Refresh the page. Now you see 99 Ether. Just deposit 1 ETH, borrow DAI. See your MetaMask confirmation pop up. Click confirm, and boom, there you go. So we deposited 98 ETH, or we had 98 ETH, so we deposited 1 ETH, and now we borrowed now we borrowed 811 DAI. Okay, awesome. So that's an introduction on how to use Aave for your smart contracts, how to build your own DeFi applications with it. Now for your homework, what you're going to do is basically find out a way to pay back your DAI. Okay, so I'm going to give you some hints here. Basically, you can repay. All right, here's a good place to look at Lenny Pool, look at repay. And what you want to do is do this in reverse. So basically repay your DAI and get your ETH back. So you want to create a new function inside of here that lets you do that. Say source contracts Aave DeFi. Okay, and then you want to create a new function here that basically is repay or something like that. That implements all these contracts and then does the opposite of what we did here, so you can get your ETH back. Okay, so yeah, that's how it works. And you can see all the other Aave smart contract interfaces inside of here. We set these up so that you can pull these in your contracts and work numbers like that. All right, so that's all I got for today. As always, I hope you like this video. If you got any questions, feel free to reach out in the chat. That's an introduction to how Aave works, how you can use it inside your smart contracts. So congratulations, you're on your way to becoming a real world DeFi developer. So that's the video. That's all I got. Until next time, thanks for watching Blockchain Mastery University.